Welcome. So, let me introduce you to probably the scariest image for anyone who is responsible for Tableau Server. Looks like this. I think we can all agree this is something we really, really never want to see. And we are happy that you also, many of you are here to talk with us about Tableau Server performance and basically get an idea of what are potential aspects you need to consider to avoid exactly this view I just showed you. A quote from one of my customers summarized it actually quite well, what we are dealing here when we talk about Tableau Server performance. We had a nice meeting, loads of enthusiastic users, and basically what he said is, took me aside, he's responsible for the entire IT infrastructure, and says, it's all very cool, I really love the excitement of how users coming and want to do this, but we really need to take care. If we cannot provide a stable and performant platform, this is all going to be of no value because we have basically no chance to distribute and actually get the information, this insights we create with Tableau Desktop or Tableau Web Edit to the wider auditorium and give them basically the advantage otherwise only single users have. To introduce a little bit to the agenda, what we want to do today. So first of all, of course, we're going to introduce ourselves, have a little bit of welcome chat. Then we're going to talk about what we actually consider performance. What is performance? It's quite a wide term, and we need to specify a little bit what we're actually talking about. We'll give you some ideas, some introduction, how you can actually troubleshoot some of this performance aspects we introduced. Then we're going to share a little bit some stories from the road, some call them usual suspects, which we frequently see in installations across the European market, which led to performance issues, so you're aware of them and can avoid them up front. And lastly, we're going to talk a little bit about prediction and eventually about how can I predict when I need to change my system, when I need to do adjustments in order to reach the performance I would like to have. Just as an info, the session will be recorded, so with video and visuals, and you also get access later to all the slides and the materials we show during the presentation. So let's firstly to us. Both of us work in the professional services team of Tableau, which is probably one of the smallest teams you're going to meet here across. You have loads of people from sales, lots of people from pre-sales. The two of us, we're actually on the road helping customers actively with their problem, with their challenges, etc. My name is Ludwig. I'm working mainly in the DACH region, supporting the biggest and strategic customers of Europe with architectural questions, etc.
And my name is Bisham. I'm the analyst consultant for the UK, but I work mostly as well in the whole Europe, helping sometimes in the DACH region, and working mainly on server performance tuning and scaling up and down the environment as well. So let's see a little bit who you guys are. So I've seen quite some familiar faces, some ex-colleagues as well in the room. And how many of you are actually server administrators?
Nice.
Nice. How many of you have ever experienced performance issues? Nice. How many of you are running Linux servers?
Okay. Cool.
And
nice.
Last thing, Tableau, who's on the latest version, which is the 2018.1?
Very nice.
10.5? 10.x?
So
you need to upgrade, guys. So, whoops. Just a few things in terms of the versioning, because we've adapted the presentation. You will see the icons as well. So the first one is the Hyper, and the second one is the Linux, as you can see. So these are just here to let you know that because of the architecture changes and things like that, so you will see the icons popping up a few times.
All right. Cool. So let's get started and let's talk about what actually performance is. And I like to quote Forrest Gump at this point because it's the same. It's all like a box of chocolate. You never really know what you get. It's quite similar with performance because you get a quite let's say, broad feedback, which is not very specific. And our job as server admins is eventually to figure out what is behind there. When we want to categorize it, we can eventually identify about 4 different categories of performance issues. The very first one on the top left is probably the one you get most, because users love to share how well performant the server is. And they're coming to you and say, yeah, Workbook is slow, it loads not, it doesn't load, it takes forever, it's a problem of the server. You're doing something wrong. Please upgrade, please be faster, put more hardware, etc. The second one, which is for all the server admins, the more reliable source of performance issues, eventually your hardware indicators. So when you see that your box is running on 80% or more of utilization, then you might identify this as a problem and say, okay, what's going on? Why is it consuming so much resources? Is this correct? Or can I change something to help? The last 2 ones are actually not that obvious, because this is something we often forget, but it's still performance issues. We have a full extract queue, so you might see loads of extract refreshes failing for various reasons. And the other one is that subscriptions or data alerts are not sent. So this is also new with version 10.3, I think, and that we also have the data alerts, and you might receive frequently feedback from users. Yeah, I set up a data alert. I don't receive anything. What's going on with your server? So we're going to focus throughout the presentation on these 4 issues. And we're going to start off with identifying how we can actually troubleshoot them. So the first thing what we like to introduce is a so-called performance troubleshooting framework. The slides are unfortunately a bit full because there's loads of things to consider. However, we still put it in just for you to have later on something on your hands you can actually follow and investigate this.
So you've got always the usual questions coming up from users, like complaining, oh yes, my dashboard is running slow, what's happening? And then you guys start going into the headache of trying to troubleshoot things. And basically this framework is just to simplify a little bit the troubleshooting. So first thing we always check is that whether the dashboard is slow on the desktop as well, or if it's related to only one single workbook. If it's one workbook, then you've got like some of the points that we've highlighted here is around the workbook design. So you will check probably the calculations, we reduce table calcs, and so on. If it's a bunch of dashboards that are causing the problem, or they're related to the same data sources, and again here it's all around the design of the data sources. Now the next point is whether, so again you've got things like performance recording that can help you troubleshoot those problems, and also we've got a white paper about designing efficient workbooks that is available you can just Google it, and it's free for you. So the other thing is if the workbook is working fine on the desktop, but on the server it's slow, then again, these are the things that you need to consider, the network, or whether you're using published data sources. If all of that is fine, so maybe it's related to the hardware of your server. And again, these are a few things that we've put here around the topology. Review the backgrounders, add vSQL, or increase the cache, or to scale up and to add more resources on the actual server. Again, we provide architecture training, and also we've got workshops called the capacity planning that we do offer as professional services in Tableau.
Yeah. So one of the aspects we highlighted here is as a potential solution for investigating what's actually going on is the performance recording. Who of you have ever used the performance recording until now? That's already great. For the ones who hasn't, I'm still gonna give you a short demo how it actually works. So if you go to Tableau desktops, the first step of maybe debugging if a workbook is actually not performant. It's the typical view you see here. And if you want to investigate what is actually doing, what's happening in the background, you can go to the section Help, so Settings and Performance, and there is a point where you can actually start a performance recording. When you start this, there's actually nothing happening on the first view, but what Tableau Desktop does in the background is actually monitoring and recording everything you do. So let's say we go in here, say we want to select a part of this data. This is interesting, but maybe I just want to highlight here the top movies which were selected. And you see that in the background there's actually something going on. Maybe it's not fast enough for your desire, but it would be interesting to know what actually happens. So when we go now back to help, settings and performance, and stop the performance recording, Tableau does what? It opens another Tableau, of course. We try to stay within our tool so you don't have to install anything separately. And it will parse all the log files which were collected in the session you started and explain you a little bit what happens. It's very interesting. We see that here a couple of queries were executed because obviously I selected something which resulted in sending a new query. And this is fairly okay, like with 1.58 seconds. But if you have there maybe a query which runs for 55 seconds, you might want to know what's going on. You might want to take this query back to your database admin and say, can you have a look on this? What was I doing wrong? How does this translate into database terminology? And the nice thing is when you select this here, you actually get the query which was sent to the database. This can be nice clear text SQL because it's a Postgres database which I'm querying. It can also be something more abstract like, for example, XML style language when you query an extract. Yeah. One tip from my side, what I frequently do, you see here that the timeline is actually indicating you what happened in relation to when it happened on the workbook. But sometimes you want to have like an actual timeline to see what went on step by step. What you can do is just take the start index from the back, just move it all the way up front, and you will see that there actually the actual timeline happening, and you also see what's quite interesting, how many parallel queries were executed. Because up here, you might see this, we have currently a parallel query set up for 2 maximum, so Tableau waits until these queries are finished before it sends the next query. This is all like fairly low level because we want to give this as a tool for people which are not actual like SQL developers and can figure out all the little bits and pieces. However, our own support team is using this also extensively because you can get really into detail. The first thing you see here is actually this event is filtered because we just filter based to the major events which we consider that they are relevant. This is queries, table calculations, vis loading, etc. But in the background there's much more happening what Tableau actually all records. So you can go down here, you see that some of them are actually summarizing parts. So this is, for example, here opening workbook, which gives you the indication how long it took overall. And it's captured in this event group. So we see on this left side here, this is actually a group. If you want to go even one step further and really want to go into detail, maybe when you have a support guy on the call, you can actually take this event name and look at this, and you will actually get the actual info what was happening within the log file. So instead of looking on a really ugly, unformatted SQL log file, you can actually go into this performance recording and get all the little steps on your own. Okay. So let's get back here. Of course, this was Tableau Desktop. It's helping at some point, but sometimes you want to also see what's going on the server because, for example, opening a workbook also is not really comparable to what you do on Tableau Desktop. So, of course, you can also do this on server. What you need to do, however, is you need to take your URL, which you just had for the view, and add this little snippet, record performance equals yes, and, very important, the refresh equals yes on the end. Otherwise, you will probably hit cache. You don't see anything in the performance recording, just a very small step which says, hey, your workbook loaded super fast, but you actually went on the cache. It might be, and there's unfortunately no actual feedback, if you type in all the things and nothing comes back, you should receive a little performance icon next to the view. This might be because it's a site-wide setting which needs to be enabled by your server admin. If this is not enabled, people will not be able to record their performance metrics on the server. You might want to, as a server admin, not enable this because if everyone records massive amounts of performance recordings, then this might have performance implications in the same time. But I guess the vast majority is not going and editing URLs in the server, so you should be fine setting this as enabled. All right. Now, we have one more performance troubleshooting framework. As pretty as they are, we still need to go through them, which is actually this full extract refresh queue. You might experience this by just getting notification, yeah, your extract was not running through. You might have users coming to you and say, you know, my data are super old. They haven't been refreshed in 2 weeks. What's going on? I set it to run on Monday, 7 o'clock, and nothing happens. So the first thing you need to investigate is this actually related to a specific data source. So you might have an issue with your database, which is just with using connections. If this is the case, you go back and test it in Tableau Desktop. So to identify if there's any networking issue, just install a Tableau Desktop on your server machine, opening it there, and see if the extract or the connection is actually possible. If this is possible, then it's slow, then you might have either network problems or you actually need to go the step and say, okay, you need to potentially modify the data source. It might be that the user put up huge data models with very complex joins and forward, backward references. He might have still all the columns in his extract, which are not really necessary because typically it comes with working on a relational database schema that you have information you don't really need. So try to work with the user to reduce the size of the data model. This brings in maybe this single case, not the incredible effect, but you need to consider with a lot of users on the server, all the small changes are helping you getting forward. If this is not the case, look at the timing. As I said, if you have, for example, one schedule available to create extracts, and this one might be Monday, 7 o'clock. Most of the users, at least in DACH, want to have it Monday, 7 o'clock, because if they come with their coffee at 9 to the desk, they want to have fresh data. The problem is, if you have all users refreshing at the same time, of course the queue is massively full. And then maybe one user figures out that he can actually change his priority for a 10 gigabyte extract to 100, and suddenly all the important extracts, they're on the back, even though they're very small, and this one massive extract blocks your entire queue. Have a look on the prioritizing, especially if you're server admin, to deal a little bit with more relevant extracts and some stuff people just put up as a fun, which are blocking your queue. If this is not related to a specific data source, then you actually need to see if it's related to hardware limitations of your server. So check if your server has enough horsepower. If it has it, you might need to change topology, especially with extracts. It's another process, the background process. We talk later about this, how they work with each other. You might want to move them, isolate them on a separate node, or actually move your schedules so you're a bit more flexible and users naturally distribute over the available thing. Of course, simplest thing, if it's not enough horsepower, if you still run your server on 8 vCPUs, what you shouldn't do, you should have 16 and it's consuming on an 8-core license, then you of course need to put in a better CPU, maybe a faster disk so you have better read and write speeds, which is important when you create extracts. Okay, so now to the next issue, and Bisham's going to talk to you about data alerts.
Just on the side note, all the sessions are recorded and the slides as well will be available to you. That's why we've scanned your cards. I've seen people just taking pictures just on that. So in terms of subscriptions and data alerts, so many times you will see that subscriptions are failing, or even the data alerts are failing, or users are complaining that they haven't received any subscriptions or data alert, and when you check on Tableau Server, it says that subscriptions have been sent successfully, but yet users haven't received it. Few things you might want to check. First of all is the SMTP setup. The second thing is the load time of subscribed dashboards. So obviously if you're trying to load like a heavy dashboards, it might cause issues where not the subscription might fail or even might take loads of time to be sent to the users. Things that we suggest is probably try to slim down the workbooks just to have the data alerts for the main workbook, where you can just link, put a link for the main workbook, so the user just have to click on the link to get access to the big dashboards. The second thing is obviously to check the spam of your email inbox, because so oftentimes we found out that users have been flagging the server URL, and these are going into the spam inbox. The last point is about priority of the data alert. So again, here, same as extract, you can prioritize when subscription and data alert are being sent. So if, for instance, You have load of extract refresh running at the same time, and also you have subscriptions as well. Priority would be given to what you've set up to the most important one. So as we can see here, on this example, the priority was set to 10, so it goes from 1 to 100.
It's actually the default priority of data loads is 10, so in comparison to everything else, it's fairly low. Cool.
And the other thing is the server admin views, which is available on the status page of the server. The server admin view is super important. It provides you, I would say, around 80% of the monitoring and everything what's happening on Tableau Server. For the 20%, we're going to see how to fill up the gaps with this. So again, on the server admin views, you've got things like to monitor the traffic of the Tableau Server, of your workbooks, backgrounders, all the tasks that are running on the backgrounders, etc., etc. And like I said, the other points where we can just fill up the gap, we're going to see that later on the presentation.
Mm-hmm. Yeah. Okay, so these are more or less the majority of steps we would undertake as troubleshooting the common performance issue we introduced in the beginning, except the hardware limitation part. We're going to talk about this more in detail later on. Let's share some, we say, stories from the road, so things we come across which are very frequently performance issues. We like to call them usual suspects because we see them like at least once a week at some place. The first thing which will be is the typical full-blown data source and workbook design. So very, very often we see the case that actually one single workbook is able to bring troubles to an entire server installation. It's like this little seed can be designed so wrong that you have issues across the platform and other users are impacted by this. We actually have this situation even for our own installation. So Tableau Online suffers this phenomena very heavily because we can't control what the user put on, and we're not in the lucky situation like you who can say, I'm the server admin, so please get off or fix your content. We actually need to deal with this, which can be quite challenging. If you have the situation, you should really look at, first of all, optimize the extract. So there's the little optimization flag you can set in a desktop, which helps you massively to write in pre-calculated fields. So everything what is like on a row level can be materialized in the extract, doesn't have to be calculated at runtime. Use extract filters. Sometimes people build massive extracts and then filter on 2 lines in the view. Doesn't help them when they need to open and load the extract actually into memory. Try to do aggregation or pre-aggregation on visible dimensions. Avoid custom SQL for most of the time because Tableau Server is not really able to deal with it, and Tableau in general does not want to overrule you as a user and say we're going to parse your custom SQL because you might have an idea which really needs the specific framework. So custom SQLs are never touched and are sent as massive blocks to a database. It's probably also not the best situation for a database. So from this point of view, try to avoid them. Look for referential integrity. It's something very often overlooked. We don't assume it by default. If you enable it to be assumed, you can do this on Tableau Desktop. It's only valid for inner joins, so be aware of this, but sometimes it really brings you an advantage because not the entire data model is always executed, even though you need just a column from one table. Of course, we talked about extract optimization. The other side, don't be afraid to maybe get in contact with the database admins. They're also interested in having a performant database, like you're interested in a performant server or a performant workbook. So if you approach them in a way and say, let's work together and see how we can optimize it, it might be easier, instead of building a huge data model in Tableau, to just get a materialized view in your database because they say, yeah, it takes us like 5 minutes, we just write it down, done. If you want to know more about this specific topic, how you can really get into detail, optimize data sources, have a bit of a strategy when it comes to huge amounts of data, I recommend you today at 16:45 is the Tableau and Big Data session, which goes into a concept which we call hot, warm, cold. It's really interesting. It's really useful to optimize the performance on a workbook level. The other one.
One of the most common thing as well that we've seen with customers is about the antivirus. So this is something that we tend to always forget and look at the loss. And we found out that, for instance, you're publishing an extract or even a workbook to the server and it's being super slow. The whole system itself is getting really, really slow. In terms of that, one thing, once you install Tableau, whether it's desktop or the server, make sure that you add the Tableau directories to the exclusion list of your antivirus. Again, for this, most of the time you will need to work with your IT team because you won't have the relevant authorizations in doing so. And the second thing as well is, if you can't probably exclude Tableau directories, is to schedule the antivirus scans during low usage times. The second thing I would say is about virtual machines. So how many of you are running on virtual machines? Nice. And this is, I would say, quite a huge topic. We won't really get into details onto that, but one of the main points is that just to make sure that you allocate the maximum resource reservation as possible, as high as possible for the VM, and also to have 100% of the processes dedicated to Tableau and not to have other processes running as well. We've got like great white papers on that, again delivered by Tableau and also by VMware on this topic, and they're all free and widely accessible. Again, if you have any questions around this, we will take questions afterwards in regards to virtual machines and all these things.
Exactly. Another topic we see quite often actually in the cloud environment is that Tableau Server slows down if you try to load big workbooks. On one hand, it can be just a TWB, so you have like someone created a workbook with 500 sheets, then this is considered like quite a substantial amount of XML code, which is included in the TWB, or that you try to load like huge extracts into memory. This actually is quite affected by the disk speed you have. So when you go, for example, on AWS and you allocate a volume to your machine, these volumes can actually be quite slow. So please look out for getting something with like around about 1,500 IOPS. So I think for AWS it would be like a general purpose volume, which is actually having flexibility. It automatically scales if you need more IOPS. Or if you work on physical machines, it should be going to the direction of SSDs or any other fast storage product, because it can actually take quite slow. You can trace this one if you make a performance recording, because you see one block which is called XML parsing, and this is going to be quite long because Tableau needs to first understand the TWB. It's like a cooking recipe, what it should visualize, and if it takes long to just load this one, you might get performance issues which are not at all related to your workbook design or to your database or whatever. It's just the sheer opening of the workbook takes long. We have seen this with customers, and we actually had significant performance gains by just attaching another volume. Another topic which is actually bringing performance issues is not really obvious from the beginning, which is more a logical problem. So we see it very often that a lot of our clients use sites as kind of like mirroring their organizational structure. Because it fits, you need like another layer of like kind of projects. But what a site is actually is a tenant. So we can define sites as containers which really separate content. This means a user which is active on one side cannot necessarily access the content or the data which is stored on the other side. So this means that at some point, even though they have both access to the background to the database, they might create the same thing twice or even more times. So you end up, you have the same data across the Tableau server replicated. It's probably the same refresh schedule attached because they have probably the same interest in getting fresh data. And it's at the end the exact same query. So what you should do, just have a look at the database landscape which is connected to your Tableau server and check if there might be duplications. And if you find some, you can like create maybe another site where say, common user pools have access to one data source, and I save myself a couple of other refreshes and extracts. And at the same time, this also protects your database because you need to consider every refresh and every extract, which is on multiple data on multiple sites, is also bringing multiple load on the database, and your database admins might not be happy about this. Yeah. The solution, what we talk about also, you can build custom repository views where you can actually trace what database is actually approached by what refresh. It takes a little bit of work, but can be of loads of value. And another tool, WSQL Lumberjack, we're going to talk later about how it actually looks and what you can do with it.
And one of the other thing as well is, as you can see, about quick filters. So the number of quick filters that you have on the dashboard does matter, and the type as well. So oftentimes we've seen that customers are using tons and tons of filters, but one thing you need to bear in mind is that each filter is sending back a query in order to get the whole list of values. So make sure you try to use a minimum of them, and also types of quick filters, filters that we do recommend. Not all the time you will be able to use it, obviously, but are like wildcard filters. So when you're typing it, then it's just going to send the query once you type the actual value for the filter.
Yeah. Okay. So these were like our usual suspects. We might have missed one or two, but we're always happy if you can give us input and say, okay, later on, yeah, we come across this and we fixed it. That's great. Now we're going to talk a little bit about, okay, we know the issues. We know when the issues occur, how we troubleshoot them. But what we actually would like to be able is to say up front, okay, how can we avoid them? Or when it would be expected that we see performance issues. So we have a couple of tools for this. The first one called Tappman. Who of you has Tappman installed already? A little bit fewer hands. It's a great tool. Unfortunately, currently only available on Windows, so you need a Windows host for it. But it's really simple to set up, and it just monitors your perfmon counters for the Tableau server, and it has already all the counters selected, so you don't need to go into detail and build your own perfmon selector. And it stores it by default for 30 days. You can set it up longer, and you get a good overview of what's actually going on your server.
The second one is Lockshock. How many of you are familiar with Lockshock? Cool. So for the rest, what Lockshock is, it's a command line utility tool basically that grabs Tableau Server log files and translate that into a workbook, and it provides you all the details about the environment as well. Again, those tools are available, the links are available on Tableau website and also widely available on GitHub as well. The next one, Jolt. How many of you have ever used it? Nice. For those who don't know about this, it's a load testing tool, and basically, like you can see, it's just simulate all the interaction on Tableau Server. Again, it's available on GitHub to download, and you can have the links on Tableau website.
Of course, there are many other load testing tools, so you're not obliged to use this one. It's potentially, we consider it the easiest option because things are preset. So you just go ahead, you install it fast, and you have something you can use.
And also they complement as well with the admin views as well. So these are the tools that might fill up the gaps in terms of troubleshooting and performance recording.
Yeah, exactly. Just this might be so. All the developments which are on GitHub, these are open source developments from our side. So some of the stuff is actually developed by our developers in their free time. So if there's a new version coming out for the product, they might hang a little bit behind. But I assure you they are already working properly on it, and it's soon going to be fixed. So just check the releases on GitHub and you get maybe an update on this. Okay, you can go to more to a session which actually goes even more into detail on these tools. So this is why we excluded them a little bit now. We just named them so you have an overview. The colleagues will introduce you actively into all the tools and what they're doing, how it's looking. So if you want a bit more detailed information, you can go to this session tomorrow. Okay, let's go. The first step we need to do is we need to understand how actually server is set up before we can talk about how we need to scale it in order to support a good performance. And Bisham is going to talk with you a little bit about sizing and architecture.
So I'm sure most of you are quite familiar with this current architecture of the server. And as you can see, there's loads of processors running, and the one that is of most importance for us mainly is the vSQL and the backgrounder. Previously on the pre 10.5 versions, we would say it's the data engine. But now with Hyper, the data engine is a multi-threaded process, so you need only one instance of the data engine to run on each instance of your server. For vSQL, basically the vSQL is the process that is used for the rendering of the workbooks. The backgrounder is the process that is responsible of all the background tasks such as extract refresh, subscriptions, and so on and so forth. And those processes are very, I would say, memory and also CPU intensive. So that's why when doing sizing of the environment, sometimes we do recommend customers to have some of the processes separated from the whole instance. So for instance, the backgrounder to have it on a separate worker running on its own so that it doesn't compete with the resources being used by the vSQL server. Like here we've just put some of the tips. Obviously it's just a few of them, but these are the most important ones, at least for us. One of the things as well, so in terms of the numbers, vSQL to cache, so 2 to 1, it can work up to 3 to 1, but again it depends on your actual hardware. Data engine, like I said, now with as from 10.5, you can set, well, by default it's only 1 and you can't change it, but if you're on pre 10.1, you can obviously increase the numbers of that. The data engine, for those who don't know, is responsible of basically running the queries and also extract creations. The third point, like I said, it's about isolating the backgrounders simply because just to avoid the competition between the resources available on the machine with other Tableau processes running, mainly the vSQL. Also isolating the repository sometimes, so if you've got like only a few vSQL running and they are getting quite busy, writing and reading from the repository might take a bit of time as well. So it might be good just to have the repository separated from the whole processes. The next to the last one is about the swapping. This is only available on Linux. So basically you can swap the backgrounder to the vSQL. So let's say in the morning you've got like loads of users connecting onto the environment, but also you have like set up, I don't know, like a load amount of backgrounders that are not being used at that time. So you can programmatically change that so it will swap the numbers of backgrounders that you have to be used as allocated as a vSQL process. Again, this is something that can be done only on Linux environment currently.
And only for backgrounders on vSQL, so you can't reconfigure in runtime other processes. Just these two are available to be scaled up and down. Yeah.
And to work out optimum numbers of vSQL processes, so as you can see, a simple equation is the number of cores that you currently have on one instance divided by 4 minus the number of cores.
No. From 4 to
4 to 2.
Yeah.
Yeah.
So the more the safe version is to divide your core count by 4 to get the number of vSQL you should configure. You can go up to dividing the core count you have by 2. So on an 8 core, for example, you can have either 2 vSQLs or you can scale up to 4, just to try to stay within this region and don't over configure vSQL services. Yeah. Okay, so that's all nice, and we know now roundabout, okay, what we should look at, how we should put number of cores into our server. So this is all relative to, okay, how much do I actually need? So very often performance issues are related to underscaled hardware, but we need to figure out somehow a concept how we can define, okay, at what point do I need another set of hardware? One thing which is very important, which I'm kind of advocate for, we should not talk about concurrent users. We should talk about TPS, throughput per second. So a very easy example. So you can have, for example, a couple of days ago, Germany played the kind of a football competition, if you follow it. So imagine you have like 1,000 people sitting, in a tent watching football, and after the scores, basically you're able to serve the entire tent with 2 persons at a bar because they're all sitting, don't want to drink anything anymore, quite happy. So the throughput is actually quite low, even though I have loads amount of users. Yesterday evening, I'm pretty sure that 5 English blokes are able to overload 2 bartenders fairly easy, just by consuming after a football event a significant amount of beers from the bartender. So you see that the user count is actually completely different, and they're all there, they're all concurrent, but the activity, what they're doing, is actually relevant. So we put this into TPS, and our recommendation starts with an 8-core server is able to handle 5 TPS, so 5 throughputs per second. This can be rendering a view, this can be querying a view for a data alert, basically all activities which are related to VisQL. And it's important, this 5 TPS are only valid for a VisQL only server. So if you imagine you have your server which is completely dedicated to VisQL processes, this means you should not include repository actions, no data engine activity, so they need to be live, the workbooks. Search and browse should not be happening right now. No background activities, which is fairly rare, this situation. No data server, no application server. So we already see everything we exclude for this 5 TPS needs to actually be considered, so we in practice are a bit lower than this. How do we define now what TPS we need? So we need to go and do some capacity planning. This is how we call it, in order to, first of all, know what's going on our server. So we're going to monitor the load, which is currently happening, translate this into the TPS, and then we either say, okay, we are fine, this is okay for now, but very often the question is, okay, I don't want to say now it's fine and tomorrow I'm surprised because someone onboarded a massive amounts of users and I'm suddenly in trouble. I want to know what's going on up front. So what I do, I design a load, I create a synthetic load in relation to TPS, especially the persons of you which have worked with Jolt. When you put this little C, the apparently concurrent users, how it's named, you're actually not putting users, you're putting TPS. You say, I want to define the number of activities which is going on at this very moment on the server. If you have this load defined, you go and generate this load and observe what's happening on your server. And you can then say, okay, with this synthetic load, I can mimic somehow my user and also my user type, because some of the users might view more, some of the users might interact more, some users might just get reports pulled out with tab command. And you get an idea about, am I in the right place? Do I need to upscale right now? Or can I upscale maybe in 3 months, 6 months? Very important, don't see this as a one-time activity. Repeat this. Repeat this in your first capacity planning and check for different scenarios. Of course, everyone in IT is like, at least it's for me, when I do Jolt, it's just see when this thing breaks. It's the most exciting moment when you see, okay, Tableau Server is no longer responsive. I did it. It's fairly easy, but be sensible about the load you design, that you can actually get a valuable information out. But do this often, because your user behavior might change. You need to monitor and you need to redesign and see what's going on. Especially, for example, for the ones of you which are, for example, promoting web editing, which is pushing a completely different style of load to the server, which is more activity-based and more query-based, rather than just simply viewing dashboards on a big screen. If you have figured out what your TPS is or what your potential TPS is going, you can take our scalability white paper, which is providing you with a really, really good detail on how you can scale. And we will actually tell you that Tableau Server is scaling linear with the TPS or with the cores you put on it. So this is a setup where we tested it with just 8 core physical machines. And just by adding another worker node to the cluster, you basically get the same amount of TPS which each of them can provide, and you can scale out. This is only valid for version 10.0 and plus. Before, the scaling of the server behaved a little bit different. You see that on the left side, this little gap, which basically highlights that we recommend to exclude or isolate the repository, not really for performance improvements, but just for protection of the data which is stored in the repository. And lastly, to wrap up before we go into the question section, we talked about this, VisQL Lumberjack and beyond. It's the last tip we want to give you on your journey with Tableau Server Performance. There is a tool available called VisQL Lumberjack. It's like a, let's say, quite creative implementation in different ways. We have guys which put this into Tableau Prep. I'm personally preferring a Python script. What you do is basically just parsing your VisQL log file, because it provides you with an incredible amount of detail. You need to be careful about this because it contains personal data. So don't publish it freely on the Tableau server so everyone can see what John at Friday afternoon sent off a query to whatever database, but you basically get high level of granularity based on a single query. You can trace every single query, database related, etc., what workbook related. We're going to take questions afterwards, yeah? And one thing which we also recommend is custom admin views. Walk the talk. We have very often customers, we talk about those custom admin views, check what your data sources are doing. Do you have specific requirements? Go ahead, take the effort, open your repository and build your own views which serve your requirements in case the standard admin views are not sufficient for you to find out what are potential issues. And with this hints, we are done. We are happy to receive questions if you have any. Yeah? Yeah? Yeah. Yeah. You see if it was an extract or a database, so you get all the queries. And you see also the runtime of the query. You also see, for example, if you pull up a workbook which has like 3 separate views, it will send 3 queries. And it will give you the information how long they ran overall, so you get an idea about parallelization, and you get also the idea how they ran on its own. No, this is all hidden in the WSQL log files. So you have in your Tableau Server, you can also go ahead and basically write this yourself. It's not very complicated. The WSQL log files are basically JSON files, which are put after another. So every line is a JSON file. And you need to look for the, it's called QP batch summary tag, and there you find the information. Yeah. Any other questions? Yeah.
Please go back one slide.
Sure.
Is not for performance, it's just for security of your data feed.
So I wouldn't call it security, it's more like a safety concern, which our developers recommend, that you have the primary node will actually no longer be a working node. It will just host potentially a gateway. This is fairly low effort for the node. The repository, your licensing service, so you have always a license available, and the base install, including the repository. So like this, you avoid the case that if your primary load is also loaded with WSQL activities and gets overloaded, if this one fails, it's your single point of failure, because your license will be gone, your repository will be gone, in case you don't run a high availability setup, and all the other nodes will not help you anymore, because your primary is gone. So try to take load away from the primary node where the repository is, to just avoid the failure of the single point of failure. And then all the other nodes are just going to be there for working for you. Yeah.
Then can you decrease the specs on your primary node?
Yeah, so me personally I would say yes, you can. So I see typically clusters that you run with 4 cores. You need to take care if you will have a support case. We request or require you that you have all the machines minimum spec at 8 cores. So they might come back to you and say, it might be an issue of this underscaled node. Please scale it up that we can get a proper testing environment. But knowing the support guys, they're also aware of that there's actually no load happening. So I would personally recommend you go for it, but it's not the official statement, just to be aware. Yeah. Any other questions? Cool, then I don't know if we overran, the clock is not working.
Still got like 10 minutes.
Still got 10 minutes, great, then we are done early. So if you have any other questions, come up front.